Everybody. Thanks for coming. Hopefully you're at the right presentation and not missing something even more exciting. I don't think that's possible. So I saw that I was last on the schedule, and I wasn't sure how to take that. I've been discussing with friends and coworkers what the technical term for being the last person on a schedule is. You have your keynote at the beginning. You often have a keynote at the very end, but to be that last slot. And I'm going to try and coin a new term here. I hope it catches on. I'm going to call it the butt note presentation. So thank you for coming to the butt note presentation. Being the person I am, I did the risky maneuver and did a Google image search for butt note. And I'm going to save you the trouble of doing it yourselves. It's an actual product, apparently, on Amazon. You can buy a butt notepad. So that gets us off to a great start. Hi, I'm Ben Hagan. Let me introduce myself first, and then we can move on to the topic. So a little bit about me. I'm currently, starting at the bottom, I'm currently at Netflix. I am the engineering manager of the Cloud Security Tools and Operations team. We're kind of responsible for the overall security architecture and security of the Amazon account that we use at Netflix. We're a pretty big customer of Amazon. All of our production services, essentially for all realistic purposes, all of our production data comes, or all of our production applications are within Amazon Web Services. So that's a pretty big stake there. The goal of the team is kind of to architect the account securely, to develop tools when necessary to help developers do things security within the account, and then to work with development teams to take advantage of security features within the account correctly. Prior to this, I was at the Obama re-election campaign for about 2 years, running their information security program. It was a great experience for me. That's really where I got exposed to kind of the new DevOps way of doing things. I'm going to use that term really loosely here. DevOps to me just means kind of programmatic access to your environment and being able to do things programmatically that you used to have to go into a data center for. So after being exposed to it at the campaign, I looked for a great place to play around with it a bit more, and I came to Netflix. Prior to that, I worked at NeoHapsis as a consultant, doing things a lot of consultants do: penetration testing, application assessments, code review, the whole spiel. And finally, I got my career started at Motorola in their Security Operations Center, and then kind of got into the consulting field at the latter part of my tenure there. I got a master's degree from Iowa State University. If any of you have friends or family who are interested in getting a higher degree in information assurance, and you don't mind being in Iowa, I highly recommend ISU. It's a great place. They have a great program. And that's my happy face on an otter. So moving on. So today, I'd really like to talk to you guys about 3 different things. First, I'm going to introduce a bit about what we do at Netflix and what that means to us to run at scale, how we utilize the cloud, and how we like to think about it. So it's going to be a little bit basic to start off with. If you have experience with Amazon, you're going to hear a lot of the same terms you've probably heard in other talks this conference, but just to kind of get the groundwork going. Then I'd like to go into deployment models, how we deploy things. So again, kind of the DevOps pattern that we use at Netflix and what that implication is for us from a security perspective. And finally, and kind of the meat of the presentation is, I'd like to introduce a lot of different questions that arise once you're running in the cloud, once you're using these really high velocity changes to your environment. What does that mean for you? What does it mean from a security perspective? And what are some solutions that you might have to those problems? So at Netflix, we've spent a lot of time thinking about these issues, and hopefully some of our patterns can be helpful to you. And we have a lot of open source software to make that adoption easier. So Netflix, hopefully you're familiar with us. If not, get a free trial. Feel free to sign up. But basically, we have around 50 million subscribers. We are growing day by day. We're expanding globally. So we're opening up new countries almost on a weekly basis. We support over 1,000 different devices. And what that means from a technical perspective is that you have a very long tail in terms of kind of technologies you need to support. So you think back to your DVD player from 5 years ago that could play Netflix. Hopefully you can still use that today. And that means we need to kind of be aware of how we depreciate technology and how we support old devices and that kind of thing. It's kind of an ongoing nightmare of needing to do things new and quickly, but also supporting the history of your service. So like I said, we're out of 40 plus countries. We're all over the world, basically. We don't have any presence in Asia right now, but Europe, South America, North America, kind of all over the place. We do service delivery from 3 different regions globally, and we treat these kind of regions as their own castle. So if you're in North America, you're probably going to be receiving your traffic from North America, either from the East Coast or the West Coast. If you're in Europe, you're probably going to be receiving your data from Europe. And we do a lot of effort on the back end to make sure data is consistent across everything, that the service is available in a transparent fashion to you as a consumer, no matter where you are in the world. And that in and of itself is a pretty big technical problem. And the kind of statistic that everybody likes to quote about Netflix is that we're kind of responsible for about 1/3 of the downstream bandwidth in the United States. So at peak usage, generally prime time at night, roughly 1/3 of the bytes going across the internet is coming from a Netflix endpoint to you, to the consumers, to the viewers of Netflix content. So that's a lot of data. The developers at Netflix. So Netflix is really, we're a media company, we're an entertainment company, but we have a huge technical presence as well. So we have hundreds of developers who work on hundreds of applications. And to the end user, really, it's just Netflix. But in the back end, we treat everything as every feature is an application to us. And we deploy things horizontally in that level. So we have hundreds of different applications. And we end up doing hundreds of pushes to production every day. So these occur whenever the developer is ready to push to production. They make a decision, and they actually initiate the process to get their code out and publicly available to you on the internet. So that's a really high velocity of change, I think. And that comes in the form of new applications, but also kind of bug fixes, feature updates, that kind of thing. So every push that goes out to production, we're doing a large scale of those every day. Our presence on Amazon, can't give you exact numbers because it's changing all the time, but it's definitely in the high tens of thousands of instances running at any given time. And that's really handling the kind of the logic of the application. What movies do you have access to? How do you physically view them? How do we work out the DRM? That kind of thing. That's all happening in the cloud. The movies themselves are served from a very sophisticated CDN network that we set up. And those CDN points of presence are all over the world as well. So the videos are actually served from a CDN, but the handshake that you can do with those videos to make sure you see them occurs via the logic in Amazon or applications in Amazon. Now, if you talk to engineering teams at Netflix, they will usually tell you, everybody says different things, but they will usually say that there is no DevOps team at Netflix. And we're not huge fans of the term DevOps, although I'll use it all the time. To us, DevOps is really the job of everybody. So every developer is in charge of their own applications. And they control they control development life cycles individually, and they control pushing their code out individually. So when you talk about a DevOps engineer, really it's an application developer. They are the DevOps engineers. Now we do have teams of developers whose job it is to make that process easier, and they're developing like tool sets to help you do this process. So we have teams of engineering tools developers, but in terms of what most people think of as DevOps, everybody at Netflix is doing DevOps. And that's really how we try and approach things. So that leads us to an interesting situation. And as a person who came from a more traditional background in security, it frightened me when I was first exposed to this, but we don't have any security gates in terms of how you deploy code at Netflix. So when you're an application developer and you're pushing code out, you don't need to come to the security team and say, hey, my code is ready to be pushed out. I need you to do a security review. Now, if you came to us and asked us to do that, we'd be happy to do it. But you don't have to. As a developer, that's up to you. We really place the responsibility of doing good security on the application development teams. So much so that every developer has sudo access to almost every instance in our environment. So that's a big departure from the world I came from, at least, where you might have deployment engineers who have access to things, but the developers generally don't have production access. At Netflix, every developer has production access. And I think that is really kind of the root of the decision we made as a company in our culture was that we are going to trust our developers. And I think that's a really big change and a really big culture shift for any organization, but we really try and hire the best developers we can find. We make security their responsibility, and we're going to trust them with that, so much so that they don't have to do a security gate at any given point in time. They get to do security themselves. We're there to help them. We're there to help them know how to do it correctly. We're there to help them develop the tools to do it correctly. But when it comes down to it, we trust them with the decisions they make, and we trust them to get their application out there in a responsible manner. So it's a pretty big departure for me, at least. So at Netflix, we use something called an immutable server pattern. This isn't terribly common within the industry. And when most people talk about DevOps, they talk about things like Puppet and Chef, and they do configuration upon launching an instance. We do things a little bit differently. So applications to us are actually application images. When we deploy something, we're deploying an image of an application. The image itself is never changed. If we need to do an update to an application, or if we need to update a library on the operating system, or if we need to push out new code, pushing out code means making a new image and pushing out a new image. And that can all be done transparently. So you have a group of images running your old version. You have a new group of images running your new version. You can transfer traffic between them. The ideal kind of textbook perfect case is that you have old instances taking traffic. You have new ones with new features, and you slowly rotate traffic onto the new instances. When you're all done and you're confident about your new feature set, you can get rid of the old ones. But in terms of changing things on an instance, we almost never do that. So when we make changes, we make new images. And that's called an immutable server pattern. And that leads to a very interesting factoid, that the time to live of an instance in our environment is under 3 days, the average time to live. So you have a version of an application running. It's launched in Amazon. It's not going to be around for more than 3 days on average. And that's because new code is being pushed out constantly. We're constantly scaling up and down. We have new things coming up. We have old things going down. We have popularity trends, all of that stuff. All of that taken into account, very few things are around for more than 3 days. Again, that's a pretty big departure from the world I was used to. So I'm just going to briefly go over this just to bring people up to speed. What is Amazon Web Services? And this is not, I'm not advertising Amazon to you. It's the solution we use. Frankly, it's probably the most advanced cloud solution right now. It doesn't mean it will be always, but for now, it's a great tool set. So in Amazon, it's a suite of cloud services. The one most everybody thinks of is the Elastic Compute Cloud. And that's kind of running your servers virtually in their data centers. When you think of VMware instances or VMware workstations that you're running virtualized machines in, that's an EC2 instance in Amazon's parlance. So it's a virtual computing environment. And to them, a virtual machine is called an instance. So when I say instance, I mean a virtual machine in Amazon. Now, they have tons of other services, too many to really go over, but it's everything from managed databases to queuing systems to load balancers to DNS. They have services for all of this. The really important part of this is that it's all DevOps friendly in that it's programmatically accessible. And we'll get to that in just a little bit. So a few very quick important concepts here. So auto-scaling groups. This is kind of how we deploy things at Netflix is in an auto-scaling group. All that means is that you have a variable number of machines serving anything at any given time. So when demand increases, you can launch more machines automatically, take more traffic in, you can provide the results, and when there are fewer requests, you can scale down automatically also. So basically during prime time for us, we end up having double the number of instances as off time. And that's handled automatically via auto-scaling groups. Security groups are Amazon's concept of a firewall. When you have a virtual machine, you need to control network access, and they call that a security group. So you allow ingress to IP addresses or other Amazon instances on given ports, and that's all done through what you call a security group. And finally, identity access management, or IAM. That's how you do access control to users. You can provision users, you can control what kind of access rights they have, and really do kind of sanity checks on what people are allowed to do. And as I said, the most important thing, to me at least, is that Amazon Web Services and all the other cloud providers are API-centric. They're programmatically accessible. And what that means is you can write code to do what you used to do in a data center by racking instances, by pulling network cables. All of that is done with lines of code now. And I think that's the biggest paradigm shift of the cloud, is that programmatic access to things. So really, DevOps to me is, as a developer of code, as a writer of code, I can now do all the operational tasks it used to take people in data centers to do. And I can do it at a massive scale. So I just want to give you some quick examples of what it actually looks like to write code for Amazon. So here, you drag this over. Does that work? No? Come on. Let's do this. There we go. Oh, that's really weird. Okay. Well, there. Okay. So here we have some code to actually access things on Amazon. This is in Python, which I think people end up using quite frequently for this kind of thing. There's really great support in a library called Bodo, which Amazon publishes, to do that programmatic access to Amazon's environment. So I'm just going to go through 3 quick examples of kind of common security type events that you can do in Amazon. So here I had the concept of security group. Something you might be interested in doing is actually finding which security groups have open access from the internet. And all we're doing here is connecting up to Amazon, the service EC2, the Elastic Compute Cloud. We're telling it to give us all of the security groups. We get those down to an object, and then we just iterate over them and say, for every security group, for every rule in every security group, tell me if it's open to 0.0.0.0, which means the internet can access it. And then you can print out your output. So with a few lines of code, you're doing what might take you hours or days in a traditional data center to go out and query every machine or every firewall. You can just do it with a couple lines of code. Next example. So in Amazon's environment, you're not really guaranteed to have a static set of IP addresses. You can request them, but by default, you're given kind of arbitrary IP addresses within the address space they own. So you may want to inventory what your presence on the internet looks like. You can do the same kind of thing. You connect up to the EC2 service. You tell it to give you all of your instances that are currently running, and you iterate over them to get out the public IP address that they're currently assigned to. So again, with a couple lines of code, you have every IP address that you're currently using. Last one. So Heartbleed. I hate Heartbleed, as I hope all of you do too. And it's a pain in the butt, but with Amazon, you can do things a bit easier here. So say you want to go to all of your load balancers that you have provisioned. That's usually where you can terminate SSL. You go there, you can query the public certificate that's on there, and you can ask it interesting things like, what is the certificate body? You can take that certificate body and parse it and get out things like the date it was issued, when it expires. You can track whether or not you've deprecated it or given a new certificate. You can use this kind of information gathering at scale to do remediation of something like Heartbleed very quickly. So that's just a few examples. Let me get back to here. So let me talk about deployment. And I think we've heard kind of the same story from a lot of people, so we can go over this pretty quickly. But at Netflix, the process is basically to people store code in a code repository, in our case Git. It's open source. Developers will commit their code when they decide that they want to push something out. They go to Jenkins. They tell Jenkins to take that code and package it into a Debian file, so a deb file that you might install on Ubuntu, Debian, any Debian-based system. It's packaged just like any other Debian file. That Debian file is then taken and installed onto a base operating system installation. So you've got a somewhat hardened version of Ubuntu. You install an application on it. You then have an operating system that has an application. You then take a snapshot of it and store it as an AMI, or an Amazon machine image in this case. We at Netflix use something called the Bakery to do all that. That is also open source. So really, this whole deployment process is accessible to anybody who's willing to use open source software. Finally, those images are deployed using a tool called Asgard, something that Netflix open sourced again. And Asgard is really our fleet management system. It's what we use to get our instances out there on the internet and to control things like auto-scaling groups, to do the version switching that I talked about. And our best practice at Netflix is to deploy things in 3 different regions, and in each region in 3 different availability zones. So the best practice example would be any given application would have 9 instances running at any given time. So 3 in every region across 3 different zones, 9 different instances. And the really powerful thing is that this entire process can be automated. So you could have it triggered by pushing new code to Git. All of the downstream tools can recognize the changes and push this entire process out automatically. Really powerful. So that's how we do deployment. And now let's talk about some security problems and some of the solutions that we've come up with at Netflix. So one thing you quickly realize when you do anything at scale in the cloud is that it's not the most reliable environment you can work in. You have weird things happening with instances. They go up and down, kind of, not consistently arbitrarily, but certainly you can never predict when there's going to be an issue. So really, availability isn't what you're used to expecting. So at Netflix, we've come out with a suite of tools called the Simian Army. A lot of these are open sourced. And I'd like to tell you about a few of them. So the little monkey guy in the middle there with the machine guns, right in the middle, centered with everybody, that guy is called Chaos Monkey. And Chaos Monkey is a mean little monkey. He will sit in the background of your environment, and he will kill off instances randomly. So you have your application running. Like I said, best practice for us, 9 instances across different regions and availability zones. Suddenly, Chaos Monkey comes in there and is like, this is too easy for you. I'm going to kill one of you off, and it'll kill part of your application. The idea here is that forcing developers to deal with this kind of inconsistently on a regular basis in a more guaranteed fashion, so guaranteeing chaos, will force them to develop an application that can thrive in this kind of environment. So that's Chaos Monkey. The guy counterclockwise from him, the big gorilla with a bazooka, Chaos Gorilla, is in the same vein of thought as Chaos Monkey. And Chaos Monkey, like I said, operates on the individual instance level. You can probably guess that Chaos Gorilla will actually kill off an entire availability zone across all applications. So suddenly, not just your application, but every application, 1/3 of it is now gone. You're happily living East Coast, West Coast, Europe. Suddenly, the East Coast is down. How do you deal with that as an application owner? How do you transfer traffic from East Coast to West Coast, and how do you do it in a transparent fashion to users? It's a tough problem, and it's one we want our developers to live with on an everyday basis. So Chaos Monkey, we run constantly. You never know when he's going to kill something off. The other two, the gorilla and the Kong, we run as exercises, basically. So there is some notice given to developers that it's going to happen, but they have to deal with it. So we need developers to keep these kind of things in mind. One other monkey that I want to go over is the guy with the James Bond-looking guy on the left, Security Monkey. It's something we open sourced about 2 months ago. Security Monkey really is meant to pick up the slack where Amazon is kind of neglecting a feature that we really wanted to see, and that is an audit trail for your environment. So Amazon is great about letting you configure things programmatically. They've recently introduced a feature called CloudTrail that logs these changes and logs interactions with their API. That's all great. But in terms of understanding how your environment is actually configured, we saw a gap there. And Security Monkey will constantly query your environment and log changes to it so that you can go back to any given state in time and kind of figure out what the configuration was. Additionally, SecurityMonkey lets you write rules based on those configurations. So say you want to know when somebody opens up a security group to the internet, you can be alerted to that. Or you want to know when you have users that don't have two-factor authentication enabled, SecurityMonkey can let you know that. Or any other number of configurations that you want to be aware of, SecurityMonkey can help you there. So I encourage everybody to take a look at it if you're running a large Amazon deployment. It's a read-only tool, basically. You install it yourself. It's very easy to use, and we'd love to hear back from the community on ways that you use it and help us develop additional rule sets to help everybody out, basically. So I really encourage you to check it out. So in summary, these monkeys are all about forcing developers to embrace chaos, getting them to understand that they can't expect a perfect world. Their applications need to be resilient to that. We do that by forcing them to be exposed to that chaos. We're looking for things that are different and making them be consistent. We're looking for audit changes. And a lot of these are open sourced. Feel free to check them out. So this logo, I don't know if you've noticed, it's pretty good, right? It's pretty professional. This is going to be the high bar for the evening. The other logos are nowhere near this. I'm just preparing you now. So another common issue, and my coworker Kevin presented on this topic earlier, so I'm not going to go into it too deeply. But the cloud is really a chaotic environment. It's more chaotic than most of us are used to. Usually it's bigger, more unpredictable than a traditional data center. How can you do your normal security tasks? How can you scan your environment with a web scanner, with a network scanner? How can you get a grasp on it in a way that makes me as a security person feel comfortable? And that's where we're working on something called Project Monterey. Unfortunately, the creator was too lazy to make a logo. So Project Monterey is all about, it's a Python-oriented framework that is plugin and manager and plugin based. The idea is to wrap individual monklets, which are kind of a wrapper around tools like Nmap, Arachni. Whatever the tool is you want to use, it's pretty easy to write a wrapper around it with this framework, and to be able to deploy that at a scale that is useful to you in your environment. So the other key feature is that it's chainable, so you have different steps. You can chain them together and have the output of one go to the input of the other. So kind of the typical use case is you scan your environment for hosts. You take that scanned host list, you run it through Nmap. Nmap gives you ports that are running web servers. You take those web servers and you pump them through Arachni. You take the Arachni results and then upload them to something like ThreadFix, where you can actually interact with them and manage them. The idea is to do that all automatically and at a scale that is useful to you. So when you're in an environment like Netflix, you have a lot of instances out there. You need to do things at a very big scale. This is our solution to that. Not currently open source, but we hope to do it in the near future whenever it's ready, basically. So that's Project Monterey. So I spoke a bit about the kind of the developer empowerment that we have at Netflix. They can basically deploy anything at any time, and we may not know about it as a security team. We find that problematic, but we don't want to impact their freedom. We'd like to know about things in a more programmatic fashion if possible. So we came up with another project. Unfortunately, the creator was also too lazy to have a logo. This one's called Penguin Shortbread, and I think the concept here is really interesting and something that you might be able to apply internally. So the concept here is that you have applications in your environment and you have a lot of interesting information about them. And based on that information, you really can infer risk or how important an application is in your environment based upon information that's easily available to you. So Penguin Shortbread takes a look at a lot of different areas of information, things like what libraries is an application using? Does it use encryption libraries? Does it use payment libraries, something like that? What network connections is it creating? What is it connecting to? Is it connecting to the credit card? Is it in the payment flow? Is it connecting to user databases? Is it doing lots of different things? What data does it have access to? What kind of databases does it go to? What does it have read or write access to? And then most importantly is how does it exist within the ecosystem of the entire environment? So how many applications depend on it? And how many applications does it depend on? Take all this information and kind of distill from that a risk ranking. And that's really like a first pass at creating a list of applications that we're interested in giving more attention to. So if you have a very high risk ranking or a high importance ranking, really, based upon this information, we know that as a team we need to give it more attention. And we can kind of use that to better handle our own time management. So that's Penguin Shortbread. We'd love to open source this kind of thing, but it's really kind of environment specific. So I think it's more interesting to apply these concepts rather than wait for a solution for it. So another problem, you have lots of traffic. At Netflix, we certainly have a lot of traffic. But it becomes a pain to track who the good and bad guys are. It becomes a pain to know what your environment is, what your IP space look like. You have some crazy traffic coming in. You have an IP address for it. You need to know if someone's attacking you, or frankly, you need to know if it's your own machine that's just doing normal day-to-day business activity. How do you track that information in a wide deployment over periods of time? And here comes one of those great logos I warned you about. So if you're familiar with a service called Fiverr, it's really great. You pay people $5 and they do something for you. And they can they'll sing a song for you, they'll record it on YouTube, they'll write you a poem. One of the things they'll do is make a logo for you. So I went to Fiverr and I said, I want a falcon. And I want that falcon to epitomize laziness. And they came back with Lazy Falcon. The name of this project, it's essentially an API-oriented database of IP intelligence and information. And it does some automated information gathering processes thrown in there too. So it basically keeps an internal history of what is our IP space, how has it changed over time. And then it correlates that with things like GeoIP lookup, blacklist information, any number of other kind of open source information. The goal is to get it into one easy to access place and make it programmatically accessible to other applications. So you're getting lots of traffic from an IP. You need to know if it's friendly, if it's not. You'd like to know the history of it. Did we ever have that IP address? Lazy Falcon is there for you. Next one. So I spoke about security groups, essentially the firewall concept within Amazon. At Netflix, we have a lot of security groups. And developers make their own security groups. They decide what access they want to have to their application and who should have access to it. We provide them guidance on how to do that. We certainly work with them to do this in a very secure and sane way. But when it comes down to it, there's a lot of information out there, and it becomes difficult to manage it. And the interfaces that Amazon provides aren't that great for it. So this time, rather than going to Fiverr, I decided to make my own logo. I'm really proud of it. Security grouper. He is the guy that looks over your security groups. That's a grouper, I found out. And the purpose of security grouper is to really act upon your entire fleet of Amazon, take information from every region, from every account that you might own, store it, and use that information in helpful ways. So the easiest way to think about it is you have a East and West Coast deployment. You want to make sure that the security groups are in sync. So you take a dump of your rules from the East Coast, you look at them in relation to the West Coast, you take that information and look for the differences. And you say, what needs to be, what can be synced up here? How can we get things to be consistent? Does one region have better rules than the other region? Can we somehow bring them into consistency? The goal here is to give you that kind of large-scale view of stuff. But the goal is also to do simple things like JSON import and export of a security group. That way you can kind of store state, you can reapply it, you can sync things up, you can lock down security groups to a given configuration. So in a kind of open environment like Netflix, we can control certain core security groups for applications and prevent people from changing them. That's the goal of security grouper. Next, and this is a realization I'm sure you've all come to at some point, the internet is a really, really horrible place. And as a company on the internet, I need to be able to deal with that horribleness in some fashion. And by horrible here, I mean people are out to get you all the time, right? You've always got people trying to hack into you. You're always having people claiming to have hacked into you. You want to be aware of what people are saying about you on the internet. You want to be able to deal with that information in a sane and predictable workflow. So we came up with a project called Scumbler. And Scumbler is there to get the scum of the internet and present it to you in an automated, predictable fashion and provide a workflow around it. So I think the easiest use case to think of here is you have somebody claiming to have hacked into your company, you set up a search in Scumbler, and you say, I want to look at Twitter and look for people claiming to have hacked me. And I want to be made aware of those and put them into a workflow that I can be sure that they're addressed. You want to gather that information, you want to store it, you want to present it to people in an easy-to-use way, and then you want to implement a workflow around it. Scumbler is there to help you out. We open sourced this a couple weeks ago, I think. We use it for things like Google, Twitter, Pastebin. When people mention Netflix, we want to be made aware of it, and we want to be able to respond to that in a timely manner. So we have this integrated with kind of our on-call process. We have people monitoring this data constantly, and we action results in the best way possible. So that is Scumbler. And it has a related project. And this is the last one I'll be talking about today. I'll be happy to take questions. The last realization is that the internet is a horrible place to take screenshots. It's kind of hard to do from a safe way. You don't want everybody just going to random websites that may or may not be malicious. You don't want them having to do it just to see what's on the website. You'd want to be able to take a screenshot of it. And this is kind of in correlation with Scumbler. We came out with something called Sketchy Screenshotter. So this guy is an API-oriented, highly scalable screenshot program or application. The goal here is to integrate with Scumbler. So Scumbler says, hey, I've got this thing on, I don't know, GeoCities has a new homepage on it, and they have bad things to say about Netflix. I don't really trust the website. I'd rather have a screenshot of it in my application. I'd rather just have an image to look at to do that first sanity check to know whether or not I need to pay more attention to it. The purpose for us here was to get that integrated into Scumbler and provide that screenshot functionality. So it's API-oriented. You can deploy it in a relatively large fashion. It's free, unlike other website services, and it's open source. So again, you can download it and implement it yourselves whenever you'd like. So with that, I think that's all of the issues I wanted to talk about, but I would love to talk about any issues you guys are having, or if you have any questions. Yep.
Are you guys PCI spend monthly?
Sure.
And they allow devs to deploy your code?
So that is, everybody asks that same question. And we do segment off certain kind of compliance-oriented parts of our network, and we do limit access to those parts of the network. And it's about doing it in a sane fashion. So we obviously seek to minimize our exposure to PCI compliance or other compliance regimes. So we have that as small an environment as we can get away with, basically. But yes, we do limit access to those environments. But it's a relatively small portion of the network. Yep.
How do you protect access to the AWS accounts? Like, do you have multiple accounts?
Sure.
How do you protect this?
So we do have multiple accounts. We don't have a really good story to tell about how we separate accounts out, but different teams may have different accounts, or different business purposes may have different accounts. And we federate access to that through a one login provider, basically. There's SAML integration with the Amazon console. You can integrate it with your corporate login, basically, and federate access out to a different provider and provide access to the console with custom IAM permissions per user or per LDAP group, and kind of give access to large groups of people, but in a controlled fashion still. So we use that. We don't, whenever possible, we try not to give out actual user accounts to the environment. We don't give out access keys unless there's a really good business case for it. We try and lock people down from that perspective. Yeah.
So I noticed that some of those tools you explicitly called out that they were open source.
Yep.
Are all those tools eventually going to become open source?
So I don't believe we have any intention of releasing paid tools at any point in time. Really, as a company, our goal is to open source anything that we think would be useful to the community. So if it's not open source now and you think it'd be useful to you, be sure to get in touch. We'd love to hear if people are interested in something. That would certainly motivate us to get it out there sooner. Yeah. Other questions?
You also mentioned that 200 plus deploys a day.
Yep.
Are all those deploys for the streaming service, or do you have that many different applications? And then also, say your old DVD player, is that a whole separate application that's having to be worked on?
Sure. The question is really, what are the 200 deploys like? Is it What context is that within the greater scope of the deployment? So by application, it's really different. So each feature is basically its own application. In terms of like, if you imagine one API, imagine the entire service is an API. Each API endpoint is kind of its own service that is then accessed through a large proxy. So each API endpoint can be deployed individually out of band with any other given API endpoint. And in terms of support for different services, it's a mixed model. So hopefully we have devices that consume the same service. We're moving towards that model whenever possible, but we certainly do have things that require specific endpoints that may have specific requirements, and those would be done kind of out of band with everything else again. Yeah. Yep.
Do you guys have problems where developers are creating the same functionality over and over and over, or how are you managing that since it's so independent, it seems like?
Sure. So the question is whether we have problems with developers kind of working on the same problem, coming up with different solutions for the same problem, not necessarily using time efficiently. I'm sure that happens. I think for large-scale problems, eventually the meeting of the minds will diminish that and minimize it whenever possible. Certainly, we kind of approach things from a service-oriented perspective, where teams are responsible for certain types of functionality. So if you need things like a persistent data store, you know that tool is available to you somewhere. You would seek out the team that's responsible for it and integrate with them before you develop your own solution. The freedom that we have at Netflix is that any development team is free to develop whatever solution they think fits their problem in whatever way they see fit. The goal is really to provide a legacy and kind of paved road of accessibility so that people are taking advantage of the same solutions across the company. So things like data stores, things like security features, that kind of thing would be centralized, and there would be one solution that people would hopefully use because it's easier for them to do it the right way than it is for them to develop it on their own or to do it the wrong way. Yep.
So you mentioned data stores. How do you handle systems consuming all your stuff?
Could you say that again one more time?
Right. So you just mentioned data stores.
Mm-hmm.
How do you handle systems of data?
Yep. Yeah, so the model of immutable servers, right? The concept is that your server is an image, and scaling groups means you come up and down. You don't know when your service is going to come up and down in individual components. When we develop something, we try and do zero persistence on the image itself. We look to outside data stores for persistence of all information whenever possible. Usually that comes in the form of a very large Cassandra cluster that's available to the company. Otherwise, if you have very specific application needs, you might be doing something like an RDS MySQL database or Postgres database, depending on your application need. But yeah, the key is to not do persistence on the individual instance and look for that persistence from the outside. In the back. Do we use VPC in Amazon? So Netflix has been around for quite a while, and we've been using Amazon for quite a while. Most of our deployment is in what they call EC2 Classic, which is the original kind of Amazon networking concept. They have since come out with something called VPC, or Virtual Private Cloud, which enables you to do VLANing, essentially. You can do your own private subnet within Amazon and then control ingress and egress from that with kind of public IPs assigned to individual instances or NAT gateways or any number of other means. It's basically a more data center-like approach to networking in the cloud. We use it minimally right now. We do use VPC, but by and large, most of the deployment is in EC2 Classic. Other questions? Yep. So elasticity is what you're saying? Yeah, so basically talking about elastic scaling groups or auto scaling groups. I don't have too many interesting numbers for you, but in general, everything is designed to scale according to demand, essentially. Demand is different per application, so it may be number of connections to a web server, or it may be CPU metrics or some other sort of metric that you're gathering from an instance. The goal is to be able to scale up and down. For us, generally, during peak hours, we end up doubling that presence on the internet. So specifically, services that are in line with the viewing of a movie would scale up to twice their size, essentially, during that primetime viewing period. As we go global, that obviously kind of melts down to a more consistent pattern, but we definitely still have peak hours where things are basically double the size in terms of number of instances. Yeah. Sure. Yeah, so talking about predictive modeling of data. So, and this is a very interesting topic, and I think we're doing a lot of experiments internally to do predictive modeling based upon previous activity from like the day or week before, and be able to pre-scale up to meet demand and not have to have that extra operation of scaling in response. We would like to predictively scale in order to save time, essentially. We have been experimenting with it. I don't really have much more to say than that, but basically we're looking at, essentially we're looking at metrics from usually the week before, just because we have very different metrics based upon the day of the week. And we look for things to be consistent in scale, and if we're comfortable with that, we can pre-scale things up or down. So for the security tools I mentioned, most of them are written in Python. Scumbler is written in Rails, basically. Throughout the corporation, again, that freedom concept comes into play. Most people write their applications in Java throughout the company, but people write in every language you can imagine. So we have things in Go or Clojure, Java, Python. I don't believe we have any PHP applications. I hope we don't have any PHP applications. So yeah, they're primarily Java from a stack perspective, but the security team prefers Python.